Up next, Team VeriVital.
Morning, I'm Ben, Senior Engineer at the UK's Defence Science and Technology Laboratory, and here with me I have Team VeriVital. Thanks for joining us today ahead of the Swarm and Search AI Capture the Flag Showdown event. First off, it'd be great to get a short introduction to the team, who you are and how you came to join the challenge.
Sure, I can start with that. So I'm Taylor Johnson. I'm an associate professor at Vanderbilt University in Nashville, Tennessee. And VeriVital is our research lab, which is the verification and validation for intelligent and trustworthy autonomy lab. And we work a lot with the Air Force Research Lab in the US, and somehow or another, we came across this competition. It looked like it might be fun to do. And we saw who in our group would be interested to help with this. And then both Bernard and Yogesh got involved trying to lead things for the competition. So I'll let them introduce themselves.
Hello, my name is Bernard Serbinowski. I'm currently a PhD student at Vanderbilt University working with Professor Johnson. This wasn't really 100% what I normally work with. Normally I'm a little bit more on the verification side. And I joined hoping to get a little bit more experience and maybe just be able to get a more tangible example for some verification setups, just as something to work with.
Hi everyone, my name is Yogesh Parve. I'm a research scientist here at Institute for Software Integrated Systems, Vanderbilt University, Nashville, Tennessee. And my area of research is in cloud computing, resource management for simulations and distributed simulations. And one of the things that I found interesting about this challenge was that there was a lot of AI and interactions with different agents that run in this large-scale simulation, which I thought might be an interesting problem to tackle, and wanted to see if I could come up with some way of doing some resource management for running these large-scale simulations in the cloud. So
we've got for you here your replay against team number 27, and VeriVital is in blue. So I'll just play that. So you've got some navigation around the buildings, which is good to see. So there's a little pause there. Then all three of your agents reach the boundary between the neutral zone and the opposing zone. So I guess it'd probably be worth talking about what you would have expected the agents to do and what the strategy was had they gone into the opposing zone.
Well, okay, so all the agents are completely hard-coded. They're not using any sort of machine learning, which is part of the reason why I'm so surprised by this. Because I know exactly what they're trying to do. Initially, they're simply going in a straight line until they encounter buildings, at which point they do one initial left turn to put the building on their right, and then they simply execute go forward, attempt to turn right. If turning right will lead you into a building, go forward. If going forward is going to put you into the building, turn left. And then they do this until they're no longer touching the buildings, and then they resume going straight towards the enemy zone. Once they reach the enemy zone, all of the agents begin searching an area centered around 450.0 or negative 450.0, depending on which side we started on. Once every integer point on that has been searched, so like 450.0, 451, 452, etc. Once each coordinate point that is made up of integers has been seen by at least one of the agents, they expand the search zone. The way the agents communicate that they have seen every point is that the agent that first decides it has seen every point, or that some other, or that between it and the other agents every point has been seen, it will stand still for a number of time units equal to the number of times the search zone has expanded. The other agents are tracking whether or not the other it can see a stationary agent. The agent should only be stationary in the case that the search zone is expanding. And through this method, the search zone expands until hopefully eventually the flag is found. The reason 450 was chosen as that center point is because after running, I don't know, around 200 simulations, I found that the flag is the vast majority of the time centered around a strip, 450.
You mentioned that you decided to use all three agents to do the search, noting that one of those is a jammer that has the ability to reduce the sensor radius of other agents. What was the thinking behind the decision to use all three to do the search?
The jammer, while it certainly can be used as a defensive agent, its speed is matched with the capture agent, and its search radius is triple that of the capture agent, coming in at 15, just barely under the 20 of the actual scanner agent, making it seem like a substantially stronger offensive agent than a defensive one. In all of the examples I was running, the primary consideration was how fast can we find the flag, which generally came down to a little bit of luck, as the flag is so is distributed in that area. So having that third agent to try and quickly find the flag seemed a lot more important than trying to deter an agent, especially since I wasn't entirely certain how well we could deter agents. If we randomly looked for the agent, there was a pretty decent chance that the scanner, that the jammer would never find an agent to deter. Whereas if the jammer simply sat around the flag, well, then finding the jammer and being told that you are being jammed means that you found the correct area, which didn't seem like a good strategy. I wasn't sure whether or not somebody would be exploiting something like this, but it was, given that there was a possibility that that was a thing someone else would come up with, and that there was a very good reason to use the scanner as an offensive agent, I couldn't really come up with a justification for not using it as an offensive agent.
I know that there's obviously the quite unexpected and bizarre element of them, sticking to the boundary. Are there any parts that you thought worked particularly well, or was it all kind of quite unexpected?
For this run?
Yes, for this run, but also, I suppose, more generally in your previous runs as well.
None of this worked as expected. In general, I was fairly happy with the sort of agreed upon in-world communication, as opposed. So we weren't allowed to send information that agents had outside of the information that they were already transmitting to each other. Figuring out that I could have agents communicate to each other by standing still or doing other such patterns to inform of like which areas have been searched already, to sort of reduce the amount of space that needs to be searched, really helped with the search time of the enemy space. So that was something I was very happy with, very excited about. A little bit disappointed to see that they didn't even bother getting to the search space in the final run.
Over the course of the competition, how did you, I suppose, approach coming up with a strategy, and did your strategy change or evolve over the course of the competition?
So the very first strategy that I came up with was just to get anything working. Like, okay, let's just have the agents get to the other side, do some, like literally just search at random through the enemy space. Improved upon that a little, make sure that we're not searching the same area over and over. And the original idea was to replace each individual segment then with machine learning versions of itself. So for instance, the approach would be replaced with, like, we just train it to make sure that it can get through the buildings each time. And then we replace that portion with that machine learned version, as opposed to the sort of really simple strategy. And then the idea was to, steadily replace portions like, okay, well, how are we determining which portion of the enemy area to search? Well, that's another thing that we could train.
What was your key takeaway, I suppose, over the course of the challenge? Is there anything particular that stood out to you that maybe you learned or took away from it?
I was surprised by how effective seemingly the sort of basic approach was without throwing in any machine learning. I was expecting to do a lot. Like one of my earlier examples got 5 wins out of 9 attempts. That surprised me. I didn't think I would do that well with a really basic approach. Kind of made me think that maybe I was overestimating what I was trying to do with like the eventual machine learning. Maybe that wasn't quite as necessary or important as I originally thought. And that sticking to just sort of basic deterministic algorithms maybe is something I should have considered a little bit more from the beginning. But outside of that, I mean, the final takeaway I'm getting is I should have, ran more tests on whatever my final submission was, regardless of whether or not I thought it was identical.